Hi everyone, my name is Nilo and I'll be teaching you on stacks. This is a topic that is covered in data structures and algorithms, or CCDSALG. So without further ado, let's get on with the presentation. So before we understand how stacks work, we must understand what it is all about. And a great way to explain this is through a stack of books. So of course, with a stack of books, the only way for you to get the book easily is to get the book from the top, which in this example is this book, because that's the book on the top of the stack. However, if you want to get a book, let's say this blue book, you must first remove this top book, followed by the yellow book, then this book here, and then lastly, the green book here. And if you want to add more books into the stack, all you have to do is just put it on top of the stack. And that's basically the behavior on stacks. So to give a deeper meaning regarding stacks, it is a type of data structure. Similarly with queues, linked lists, or heaps, or rather arrays, this is also a type of data structure that follows the last in, first out principle. So just like in the example of books, whatever is recently placed on the top will be the first one out. And the top element is the only accessible element. So like I said, whatever book is on top, that's where you could either remove the book or you're going to be adding a book, which will now be the new top. So that's basically the definition of stacks. So let's get on with the stack operations. So in total, we have 1, 2, 3, 4, 5, and 6. We have 6 operations that covers in stacks. So let's try to understand each one of them. So firstly, of course, in order for you to have a stack, you must create a stack. So using this convention here, create, that takes into one argument, which is the stack. This will create or make an empty stack. Then, since you have a stack, you want to add some elements into it. So you're going to use this function called push that takes in 2 arguments, which is the stack and the item. So this item will be inserted into the stack. And let's say you have a lot of elements in the stack and you want to remove it, or you want to remove an item. So using this convention, pop, that takes into one argument, which is the stack itself, this will return and this will remove and return the top item from the stack. So let's say you have a stack with 3 elements and you have inside of that stack has already 2 existing items. So let's say 2 and 3. You have an items called 2 and 3. If you're going to be using the pop, it's going to return the value 3, since that is the most recently, or rather the most recent item that was placed in the stack, and then it's going to be removed from the stack. So we'll get into the examples pretty soon. But that's basically how it is. You're going to be returning that top element and you're going to be removing it from the stack. And then you have the 4th element here, which is top, which takes into one argument, which is stack. This will return the top item from the stack. So similarly with the pop stack, it will return the top item from the stack, but it will not be removed from the stack. And the 5th operation here is called stack underscore empty, or basically stack empty, which takes into one argument, which is the stack itself, and this will determine if the stack is empty. So obviously, if the stack has no items, then this will return true. Otherwise, it will return false. And lastly, you have stack underscore full, or stack full, which takes into one argument, which is the stack, and this will determine if the stack is full. So if there are already no elements to place from the stack because it is full, it will return true. Otherwise, it will return false. So let's try to learn. Let's try to understand the operations with the simulation. So I created a stack which is called blocks, and since I use the operation here to create, this will create or make a stack, and the top index is at 0 for this example. So 0 here is technically out of bounds. So it's like, of course, with your CC prog to understanding on arrays, which the indexes are from 0 to n minus 1. For this example, I'll just be using index 1 to n, so that it'll be easier for me to explain to you. So yes, so top index is at 0, and then I have 5 elements in the stack, so it's labeled from 1 to 5. Now I just want to simply verify to know if the stack is empty, so I called in stack underscore empty, which takes into one argument, which is the blocks, which is the stack that I created. And obviously this will return true because I have no elements, or rather no items in the stack. Now I'm going to be pushing, or I'm going to be inserting an item into the stack. So I have a value, I have an item called 20. So this number 20 will be placed into the stack. Now the top index is at 1. So since we have now something, now the top index is at 1, so it's like a pointer which is labeled at t, and it has an item called 20. So that's basically it for this. Now if I'm going to be calling stack empty, this will obviously return false. Now that we have an item in the list, or rather we have an item in the stack, by logic this should not return true to know that if the stack is empty. Now I'm going to be pushing another item into the stack. Now I'm going to put the number 45, and the top index is now placed at index number 2. So now this is the top stack, or the top item rather. Now I just have a feeling that I wanted to remove the number 45, or rather whatever is on the top of the stack. Now I'm going to be using the convention pop, which takes blocks as its argument, and then this will return 45 since it is the most recently pushed item, and the top index is now back to 1. So technically speaking, in this diagram, the item 45 is still in the array or in the diagram, but it's no longer in the stack. So basically the item here is still in this diagram, but it's no longer part of the stack. And you're gonna see why. So let's say I'll be pushing another, I'm going to be pushing another value. So it says, so I'm going to be pushing the item 60 into the stack. Top index is now at 2 again, but this time you're not gonna see 45, but rather you see 60. So that's basically how it works now. If you're going to be popping and then you're going to be pushing an item, then basically I push an item again, which is 35. So it's now the top index is now at 3, followed by 70, and then followed by 10. And then if I'm going to be calling stack full, this will now return true, since as you can see here, since my stack has can only hold 5 elements, now it's going to return true. And I think I forgot to mention regarding the top function. So let's say let me annotate this. So let's say I'm calling, since this is the diagram right now, let's say I'll be calling top blocks. This will return the top. This will return whatever is on the top index. So it will return 10. So basically, if you're gonna call this one, this will return 10. But for instance, if there is nothing here, and the top index is at, let's say, 4, because you pop this item, this one will return 70. That's only if you're going to be popping this. Just assuming that one so that you'll not get confused. So if the top index is set here, it's going to return 17. So that's basically it. Okay. So however, in stacks, there are two possible errors. So there's the overflow. So you attempted to push an item when the stack is full. So in the previous example, if you're going to be pushing an item, that's no longer possible. So that's going to be causing a overflow error. And underflow, you attempted to pop an item when the stack is empty. So if you go back here, stack, if you're gonna, let's say you have an empty stack, and then you're going to be popping it. That's not possible because number one, there's nothing to there's nothing to remove from the stack since it's empty. Therefore, it's going to be called underflow error. And that basically is the discussion on stacks. Thank you for listening.